Now let's take a look at a molecule called ethyne and the atomic orbitals used in that. So that would have a chemical formula of C2H2, which you could represent like this. Or you could represent it like this. Or, well, let's go back. Or like this. Or you could draw it like this. Okay. And so now, what is that going to look like? Well, first we need, to answer that question, we need to take a look at that carbon there and ask, well, what is its hybridization state? And so we could expand that hydrogen out if we wanted to make it a little bit easier to see that that carbon has 2 electron groups, making that sp3 hybridized. So let's take a look at how that looks here. So carbon, carbon. Are they going to let us do a triple bond? Let's see. Oh, they do. Beautiful. And then we would have our hydrogens extended off like that. Look at that. That is a linear molecule. It's nice and flat. So you can get an idea there with those triple bonds. Okay, let's draw the atomic orbitals here. So what we have going on here is an sp2 hybridized carbon is going to have, if we go back to the ground state, our 2s and 2p, like this. We're going to hybridize it, and so we will have, how many degenerate orbitals are we going to have? Well, what does sp mean? We're going to take one s and one p, and we're going to make those 2 degenerate. So that's our sp, but we haven't touched those 2 right there, so they just come straight across. So those would be our 2p orbitals. How many valence electrons does carbon come with? 4, just like that. So if we draw our molecule here, let's do orange carbon next to a blue carbon, like that. And yeah, okay. So we're going to have blue doing the same thing. No, not sp. That would just be p or 2p. And those are sps. Like that. Let's change the color there. And then how many hydrogens do we have? We have 1 hydrogen. That's not what I wanted to do, but apparently that's what it thought. Okay. And then we have hydrogens coming in with a 1s orbital, and there's 2 of them. So let's draw our molecule here again. I'll just expand it right here. Maybe not, a little bit further up. Okay, so here's our orange carbon here. And when we looked at the structure here, you remember how it was completely flat and linear? So what are the bond angles here? From there to there, 180 degrees. So that means the sigma bonds here that we're going to take a look at, this sigma bond and the one in the middle, okay? Do you see how they're 180 degrees from one another? So that means that we're going to have a sp orbital there and an sp orbital there. Do you notice how that bond angle right there between those 2 sp hybridized orbitals are 180 degrees from one another. Okay, and so then the same thing's going to happen with the carbon, the blue carbon. Those are our sp hybridized orbitals, and that comes with an electron, and that comes with an electron. That comes with an electron, and this one comes with an electron. Okay? Our hydrogens are, well, let's first do the carbon-carbon overlap here, like that. Okay? Now we have a head-to-head overlap. That would be our sigma bond. There's our sigma. And then if we take our hydrogens, there's going to be one hydrogen here, because we can see it there or there. Now, and then we add in our other one. So now we're at 0. So we've accounted for all the hydrogens. And so when we've accounted for all those electrons, but except for those two and those two, because all we've really accounted for are the 3 sigma bonds at this point, which are represented there and there. Those are the sigma bonds because it's head-to-head orbital overlap. Now we have 2 different types of p orbitals here. Not different, it's just their orientation in space is going to be different. Okay, and so we are going to have green and green. And then what's a different color I could use here? Which one do I want? I guess I'll use red. Okay, red and red. So let's draw the green p orbitals. And they're going to be perpendicular to the sp hybridized orbitals, like this and like this. Draw on the phase. And so this green electron I'll put here, and then this green electron I'll put here. So now we're going to have orbital overlap above and below this plane. Okay? And now we have to account for the red ones now. So with respect to the green p orbitals and the red, they are also going to be perpendicular to one another. And the way that we're going to draw that is this way in phase. Like this. And now we're going to have side-to-side orbital overlap between those two. I know, it's really, really messy looking. Your textbook gives you a really good, a little bit more clearer representation. But I'm showing you guys how to draw them because that's what I want you guys to be able to do. So what we have going on here is the green orbital overlap is going to be our pi. So that's a pi interaction. And that pi interaction is going to be represented right there. And then we have the red p orbitals interacting. That is also pi because it's side to side. And we can represent that at the very bottom. So if we draw this again, we have our carbon. And this would be our sigma bond. Sigma. No, not. Sigma. Sigma. Pi. And pi. So how would you describe the bonding for that bond right there? You would say, well, you have a carbon that is sp hybridized, bonded to a hydrogen, that is 1s. And so that would be the exact same. How would you describe the bonding between those two carbons? Well, you would say you have a carbon that is sp hybridized, forming a sigma bond with the other carbon that is also sp hybridized. Those same carbons also have a p orbital bonded to another carbon with the same p orbital. But then you also have the same carbon bonded to the same carbon, but we are now going to use our red p orbitals. And so that's how you would describe the bonding between those two carbons, is that it's using all of those atomic orbitals to get that job done. So you could say that that triple bond is going to use 1 sigma bond and 2 pi bonds. And that is our triple bond between those two carbons, like that. Okay, that should do it. I hope you find that helpful, and if you need additional help, please let me know.